In today's lesson, we're going to work on 1.4a. I decided to split up 1.4a because there's multiple things to cover. So before we worked on the 1.4 class practice, I'm going to go over the problems related to 1.3. So here's our first question relating to 1.3. When you're solving this, so what I'm going to do is I'm going to take a look at this 4. It's directly in front of the parenthesis. So the 4 is going to be distributed to the 2x and the minus 1, or also known as negative 1. So it's going to be 4 times positive 2x would be a positive 8x. Positive 4 times negative 1 would be a negative 4. Then equal sign. So I'm going to do the same process with this negative 3. Notice how the negative 3 is directly in front of the parenthesis. So I'm going to distribute to everything that's inside the parenthesis. So negative 3 times 3x would be a negative 9x. Then negative 3 times positive 7 would be negative 21. So when I'm solving this, I can do 2 steps at once. What I'm going to do is I'm going to have all the x's on the left side. So notice how you have x on both sides of the equal sign. So what I need to do is get rid of negative 9x. So the opposite is a positive 9x. So I'm going to add 9x on the right side. Since I did that, in order to balance, I need to do the same thing on the left side. So add 9x. And since I'm getting all the variables on the left side, that means that on the other side of the equal sign, I need to have numbers. So since I have negative 4 or minus 4 on the left side, I need to cancel that out. So in order to cancel out, I will do the opposite, which will be plus 4. So since I added 4 on the left side of the equal sign, I need to balance. So I'm going to do the same thing, same operation on the right side. So I'm going to add 4. So once I do that, I can start combining variables and combining numbers. So when I combine my x's, positive 8x plus 9x will be 17x equal. Then my numbers, negative 21 plus 4, opposite sign, I'm going to subtract the numbers, so negative 17. So here, negative 4 plus 4 cancel out. You're not required to write the 0, but you could if you wanted to. So you could say plus 0. Same thing over here, negative 9x plus 9x, that would be a 0. And like I said, you're not required, and the reason is here's why. 17x plus 0 is just simply 17x. 0 minus 17 will be negative 17. So it's ultimately the same as before. So when I'm solving, then I just need to get x by itself. So I'm going to divide by the number that's in front of the variable, which is x. So I'm going to divide by 17. So I'm going to be left with x equal negative 17 divided by 17 will be negative 1. And that will be my final answer. And I'm going to box this up. So here at the very beginning, I did 2 steps at once. I cancel out the negative 9x by adding 9x to both sides. And then I cancel out the minus 4 on the left by adding 4 to both sides. So I did 2 steps at once. So that way I ended up with just 17x on the left side of the equal sign. And I ended up with negative 17, the number on the right side of the equal sign. So that's basically what you need to do for solving an equation. So next, we're going to move on to 1.4 examples. So in example 1, this is pertaining from 1.4a number 1. We have a big fraction, 1 minus 2 times the absolute value of 3x minus 1 over 3 equals to negative 3. So when we're solving, the goal is to get the absolute value by itself. What I mean by that is you don't want any numbers in the front of the absolute value. And what I mean by absolute value are these two lines that you see here. So in the moment, we have two numbers in front of the absolute value. We also have one number that's below the absolute value. So we're okay because we don't have any numbers behind it between the absolute value and the equal sign. So we just need to worry about the numbers in the front and below. So what we need to do is notice how you have the 1, the -2. Even though it's in front of the absolute value, it's also above the 3. So like I said, it's a big fraction. So we're not going to mess with the top part first. What we're going to do is worry about the denominator. So in order to get rid of the denominator, I'm going to multiply both sides by the denominator. So I'm going to multiply by 3. So what happens here is when you multiply by 3, this is what's it going to look like. So that's what the top is going to look like. Remember, when you multiply in a fraction with a whole number, it multiplies to the numerator. So this is my original numerator, 1 minus 2 times the absolute value of 3x minus 1. Notice how they're the same? So the only difference is now that the 3 that I multiply by with is in the numerator. And let's simplify the right side. So negative 3 times 3 is negative 9. So the one thing I want to illustrate is that this 3 in the numerator and 3 on the bottom. Now you might have heard where it says cancel out. I don't use that term cancel out. Cancel out means that it equal to 0. So let me bring it back to the previous example. So these two lines that you're supposed to see here, that means that they cancel out. Notice how they have the same number and opposite sign. So when that happens, when they cancel out, it equals to 0. Now, most of the time you haven't seen people write the 0, but I'm writing a 0 to illustrate it's there. It's just it won't change the numbers in the equation. Just like the negative 9x and positive 9x, when you combine it by adding and subtracting, it will cancel out and come out as 0. Now, here, you're not adding and subtracting, you're just dividing. So that's almost identical to what you have here. You see you have negative 17 divided by 17. Now, I'm not going to worry about the sign, but if you take a look at the number, 17 divided by 17, it came out as 1. So I'm going to do the same thing over here. When you have a whole number being divided by the same number, then it's going to become 1. So let me underline the 3's. So it's ultimately become 1. Then this part will stay the same. So I'll put parentheses 1 minus 2 absolute value of 3x minus 1 absolute value, and then equals to negative 9. So if you look closely, anything that multiplied by 1 will stay the same. So I'm going to have 1 minus 2 times the absolute value of 3x minus 1 equals to negative 9. So next, in order to get the absolute value by itself, I'm going to have to get rid of the number, which is the 1. I'm not going to mess with the 2. The reason is the 2 is multiplying to the absolute value. So I'm not going to mess with that one. The 1 is not multiplying, so I'm going to get rid of the 1 first. So in order to get rid of 1, I have to do the opposite. So subtract 1 on the left side of the equal sign. So I'm going to do the same on the right side. So remember, these two 1s, they cancel out. I'm not going to write the 0, but you feel free to write it. And you see that it will not make a difference whatsoever. Now remember, negative 9 minus 1, They both have the same sign, so I can just add up the numbers and keep the same sign. So negative 10. So again, here we have 0 minus 2 times the absolute value of 3x minus 1. So that's the same as negative 2 times the absolute value of 3x minus 1 equals to negative 10. All right, I'm going to bring it up to here for more space. Now, even though you see that this absolute value is equal to negative 10, we're still not finished because we have a negative 2 in the front of it. Again, this is multiplying. So we want to make sure that we get down to the absolute value part only to see if we can continue solving. So here we have a negative 2 in the front. That means that it's multiplying. So the opposite of multiplying is dividing. So I'm going to divide by the number that's in front of the absolute value, which is the negative 2. So divide by negative 2, divide by negative 2. And again, just like before, you see these two 3's here, it became 1, and you're left with what's in the numerator. So I'm going to do the same thing here. Negative 2 divided by negative 2 will become positive 1. Positive 1 times what you have in the numerator is the absolute value of, excuse me, so as I was saying, the absolute value of 3x minus 1 equal negative 10 divided by negative 2 is positive 5. So now I got the absolute value by itself. You don't see any numbers in front, you don't see any numbers below, and you don't see any numbers between the absolute value and the equal sign. That means you're good. Since it equals to positive 5, I can actually keep solving. Had this equal to a negative number, then this is where you stop and write no solution. So I repeat, had this absolute value equal to a negative number, you stop and you just write no solution. But since it's a positive 5, that means we can keep going. So we're going to write our two equations. So we're going to write 3x minus 1. I'm just writing what's inside the absolute value, and I'm going to set it equals to positive 5. Then I'm going to write the second equation, 3x minus 1 equal to what's the opposite of positive 5? That's negative 5. So notice how I didn't write the absolute value lines. The reason is because now I'm solving for x when the absolute value is by itself. So when you're solving, you don't need the lines anymore. You just write what's inside. 3x minus 1, 3x minus 1. One equation will equal to the original number. The other equation will equal to the opposite. Now, the reason I wrote them side by side is so that you can see what I'm doing. So in order to solve, now let's take a look. I need to cancel out the minus 1, so I'm going to add 1 to both sides of the equal sign. And if I take a look, 3x minus 1, I need to cancel out this one too. So I'm going to do the same thing on both sides. So when I'm solving, on the left side of the equal sign is just 3x, then equals to positive 5 and positive 1 would be 6. Same thing over here. 3x equal, now negative 5 plus 1, that's going to become negative 4. Next, I'm going to start solving. So I'm going to divide by what's the number in front of the x. So the coefficient that's in front of the x is 3, so I'm going to divide both sides by 3. And I'm going to do the same thing over here because the 3 is in front of the x. So my first solution, I'm going to write as x subscript 1 or x sub 1. 6 divided by 3 is 2. And our second solution, x subscript 2 or x sub 2. Here, we can't simplify it, so it's going to be negative 4 over 3. It's going to be a fraction. So you can have a whole number and a fraction as your two answers. You can have two whole numbers as your two answers, or you can have two fractions as your two answers. You never know what you have when you solve. But these are our two answers. X sub 1 equals to 2, and x sub 2 equals to negative 4 over 3. So those are our two solutions. Now, I mentioned before I wrote these equations side by side is so that way you can see that the first step, I added 1 to both sides, and I did the same thing for both equations. When I finished with step 1, my next step is I divide both sides by 3 to solve for x. And again, you see how I did the exact same step for these two sets of equations. So when you're solving, you're just doing the same step. Again, this is what happens when you have the absolute value by itself and you break it down into two equations. Notice how you have the same first step and the same second step. But as long as you do it correctly, you may get different numbers, different signs for your two answers. In this case, I have a positive 2 and I have a negative 4 over 3. So I'm going to do the same process in the next example. So in this example, this is from 1.4a, number 2. So we have a big fraction plus a number, the plus 7 equals to 8. So let's take a look. We have the absolute value of n plus 12, and then minus 1 over 6, and then plus 7. So what's different is that we have a plus 7 that's not part of the numerator. So let's go back to the previous example. Here we have a big fraction where everything is in the numerator. So we had to get rid of the denominator first. Not in this case. Since you have the plus 7, it's not part of the fraction. So the plus 7, that one you have to get rid of first. So what I'm going to do is I'm going to cancel out the positive 7. So the opposite is minus 7. Since I did it on the left side, I have to do it on the right side. So when I do that, the 7 will cancel out. So I'm only left with this fraction, the absolute value of n plus 12 minus 1 over 6 equal 8 minus 7, 1. So now it's almost identical to the previous example, as you can see here. So in the previous example, I multiplied both sides by the denominator. So in this case, I'm going to multiply both sides by the denominator, which is 6. And just like in the previous example, when I multiply by 3 on both sides, the 3 in the numerator and the 3 in the denominator, they both divide into 1. So in this current example, I multiply both sides by 6. So this 6 is going to be in the numerator. So that means that 6 divided by 6 will be 1. And since it's 1, I'm just left with the numerator. So the absolute value of n plus 12 minus 1 equals, on the right side, it's 1 times 6, so 6. Next, in order to get the absolute value by itself, I have to get rid of the minus 1. So the opposite of minus 1 is plus 1. So I'm going to add 1 on the left. Then I need to do the same thing, add 1 on the right. So when I added 1 to both sides, what happens is these two 1s cancel out. Like I said before, you don't have to write the 0 because it won't change whatever you have on the left side. So when the 1s cancel out, I'm going to have the absolute value n plus 12 and then equal 6 plus 1 is 7. So now if you take a closer look, I have the absolute value by itself. I don't have any numbers in front. I don't have any numbers between the absolute value and the equal sign, and I don't have any numbers below, so I can continue solving them. So when the absolute value is by itself, let me write it over here. Absolute value of n plus 12 equals to 7. So what I'm going to do is I'm going to split it into two equations. I'm just going to write the inside twice. So n plus 12 equal to the original number, which is 7. Then I'm going to write the inside again. N plus 12 equals to the opposite of 7, which is negative 7. So now I'm going to start solving it. So in order to solve for n, on the left equation, I'm going to subtract 12 on both sides of the equal sign. Then on the right equation, I'm going to do the same thing. Cancel out the positive 12. I need to subtract 12 to both sides. So let me do this part first. So when I'm solving, I'm going to have n equal 7 minus 12. That's going to come out as negative 5. And then here, n equals negative 7 minus 12, same sign. I'm going to combine the numbers and keep the sign. So my two answer is n sub 1 is negative 5 and n sub 2 is negative 19. So let me write it over here. So they both come out as whole numbers and both negative. So in some cases, you might have that as your set of answers. So I'm going to box up our two final answers together. So n sub 1 is negative 5 and n sub 2 is negative 19. So like I said before in example 1, you might have cases where the two answers are opposite sign. In this case, example 2, they're both the same sign, but different numbers, negative 5 and negative 19. Example 1, you have a positive 2 and a negative 403, which is a fraction. So you never know what kind of answer you have until you start solving it all the way through. So this is pretty much what you have to do when you're solving absolute value when dealing with big fractions.